Good morning, good evening, students. Today we are going to see an important topic that is the pre-processing in machine learning. So I will share my screen. Yeah. So I hope you can see my screen sharing. I hope you can see my Windows PPT. Yeah. So today we are going to see the topic that is feature selection and feature extraction. So from the figure itself, you can understand that some of the features have to be selected, which is if the data points or data which is present inside that is abnormal, and if it is missing, or we will see the different properties why we are selecting only the particular features. And then feature extraction means we are going to transpose the data and we are not going to miss any information which is present inside. So mainly this process we are doing to improve the accuracy before entering into the machine learning model. So when you see here, you can see that the raw data we are moving in the process of feature engineering, and then we are making it into a meaningful features, and then we are passing it into the ML model, right? So for feature engineering only, we are going for feature selection and feature extraction process. Feature selection. So as I told you, some of the features will be removed, and then we will pass out to the ML model. And sometimes feature extraction means we are not removing, but we are just transposing the information which is present inside, and then how we are going to do it with the different methods we are going to see in this particular exercise. So for that, first we are going to go for splitting the data. As we know, the training and test data we have to split. Okay, so mostly 80-20%. So that's why the test size we are giving in the syntax as 0.2. That means 20% of we are going to use it for the test size of the whole data set, and then the remaining 80% for the training set. And then we are giving the random state. Why? Initially, we are going to pick the data records 25, uh, okay, randomly, and then keep on when we are going for testing. We are using the same set of data what we chose randomly, because then only we will not reduce the accuracy, right? So this is how the syntax for train test split will be done based upon the percentage and the random state size. And then we are going for the feature selection. So here the process of selecting a subset of relevant features from the original features to reduce the model complexity. So that's why we are reduce the generalization error introduced due to noise by irrelevant features. Which are all the irrelevant features that we are going to remove? That is the feature selection. So these are the different methods. See, for example, first feature selection methods. Here we are removing the unused. Okay, we are removing the unused column. That means what? Unused columns sometimes in the data set. If you are having the employee ID, say for example, employee ID, we are not going to use for any analytic process. We are going to consider that column as an unused column. That we have to remove it to improve the accuracy. Similarly, remove columns with outliers. Sometimes for financial record, see for like month wise, if you are taking, sometimes if it is a seasonal business, means like December alone, the particular product will be sale more. Okay, so that is the time that will be considered as an outlier, in which the stack will be done only on the month of December. So such column we have to remove it. So how to remove? We are using some formula, and we are removing the outlier here, right? And similarly, remove features with missing values. So we are going to check the particular column up to 80%. If it is there, then we are going to go for a go for the model. Okay, so ML model, or otherwise we are going to remove such columns to improve the accuracy. And then remove features with the low variance. So what is this means about the low variance? Say for example, we can see here. Sometimes if there is like if you are having a United States company base, okay, so such times country will be there. Most of the information will be like the same US, United States, like only a country. We are not going to have different countries there. So such redundant values, okay, containing columns have to be removed. So that we are going to check using the formula low variance and such have to be expelled before passing to the ML model to improve the accuracy. And finally, and then remove the uncorrelated features that we are checking for the correlation between the different columns. And then if it is uncorrelated, that means checking with the target and if it is not even get connected with. So such features have to be removed. And then remove highly correlated, equally. Mostly it is like a homogeneous with a target. Such features also have to be removed. Okay. So we will fix the threshold like between -1 to 1 means only not closer to 0 or not closer to 1. We have to take such okay correlated values alone. Then only it will give the best result with the target. And okay, and remove, okay, and then univariate feature selection. Okay, so such thing also we have to check for example, if you are going for a correlation, okay, covariance, you will know, okay, only the triangular part, the other triangle will be like as similar, right? So we have to take removing the diagonal and only that triangular part in the upper part. If we take that is alone, that is enough. That's why we are telling that univariant feature selection in order to avoid of taking both, okay, values repeatedly. We can take only one portion and we can do the analysis. And information gain, okay, so using the information gain based feature selection, that means we are going for statistical thing, and how we can do it we will see in the coming sessions. Okay, so how we are going to use the size square and how we are going to calculate the information gain and such features alone to be selected to improve the performance. So these are some of the syntax for unused columns to remove, drop column 1, column 2, like which are all the columns which are unused. We are giving in comma in the form of a list, and along the columns axis equal to 1, we are removing the columns, right? And then with the outlier, that means mean and median. Mean means it is like an average, and median means it will be like an middle value, right? So we are just, as I told you, if the data set, if it is not equally distributed, it is like very dense form of data. Such okay column can be considered as an outlier, and that have to be removed. So we are using this formula and finding the mean and median, and which is less than median value. If it is greater, then consider as an outlier, and that such column have to be removed. And then missing values. So we are putting then greater than 20% means we are finding the okay formula by mean into 100. That is 100 percentage calculation. We are finding out in the average, and if it is the null, we are finding that in the range which is greater than 20, at least 80% of the information should be available. Then only we will consider that as an required one, or otherwise we are going to remove it, such columns. And then remove the features with the low variance. As I told you, some columns, if it is like a country or something, the redundant information will be the same information will be repeating, right? So such column using the variable function, variance function, we can just remove it. Okay, so directly we can use it. And then uncorrelated features. See, for example, we are going for uncorrelated feature, that is log of target, finding out with the correlated, and then finding the uncorrelated with the target less than zero point 0.2. Okay, that is 20%. Okay, if it is if this condition matches, then we are considering as an uncorrelated feature that have to be dropped. And then highly correlated. So df dot cor is a function we are going to predefine function we are going to use. which is greater than zero point 0.8. So initially we are saying point less than zero point 0.2, and this is greater than zero point 0.8. So between this range only we are considered as the best correlated features, or otherwise if it is high or low, we are going to remove it before passing to the ML model. Okay, and then going for univariate feature selection. Here also we are going for a statistical test. Okay, can help to select the independent feature that have the strongest relationship with the target feature. Okay, so here we are considering the scikit-learn library, which provides the select k-best class. So we are using the k-best model, in which a chi-square is a statistical method we are going to use, and k, that is equal to 10, that is nearest neighbor. We are finding out like 10 neighbors. We are going to fix it, and then we are going to fit the transform that is between the x and y plane. If you are finding this particular thing, okay, then we can consider such thing have to be selected. Okay, univariate feature selection. So we are setting the nearest neighbor range of okay value, and then chi-square test we are selecting, and then select k-best model. Okay, we are using it for the x best. Okay, so this is how we are finding out for the univariate feature. This is the syntax we are using. And finally, information gain based feature selection. This is like it calculates the mutual information value for each of independent variable with respect to the dependent variable, and select the ones which has most information gain. Okay, so how to calculate the information gain? We are just giving the features scores. Okay, so equal to mutual info classify. Okay, x comma y random state equal to 0. We are just using the classification model. Okay, so in which we are just calculating. Okay, the highest score. Okay, so then we can say that will be considered as the more dependent variable. Okay, so that we are calculating using the information gain, and we are selecting the feature, right? So these are some of the feature selection methods. And now, as I told you, feature extraction. In the previous feature selection, you are dropping certain columns and we update. But in feature extraction, we are not going to drop it, but we are going to transpose it, and we are going to not miss any information, and also improving the accuracy. Both are helping us to improve the accuracy, but here we are not missing out the data as well, right? So that is the process. We are going for feature extraction before going for the ML model. Feature extraction refers to the process of transforming the original features into the new set of features that preserve the information into the original data set. So preserving the information, right? So it also yields the best result than applying machine learning directly to the raw data. Okay, so that is the main thing we are using. So here we are going for two analysis. One is PCA, principal component analysis, and one other one is LDA. Okay, so that is LDA, that is linear discriminant analysis. Okay, so for principal component analysis means here it is a dimensionally reduction technique that enable you to identify the correlation and patterns in the data set, so that it can be transformed into a data. Okay, in a lower dimension without loss of important information. So mainly we are going for this PC and LDA. We are not going to lose any data which is present in the data. That is the main purpose of it. So here, what are the steps? Okay, so first we are scaling the data within the similar range. Okay, so sometimes the scaling will not be done. It will be like a scale of X or Y. If it is abnormal, okay, then it is very tough for us to do the analysis. First, the scaling process will be done. And secondly, we are computing the covariance matrix, that is correlation between different variables in the data set. As we know, two pair like the correlation we will done for all the pairs, and then calculate the eigenvector and eigen values for the covariance matrix. So then what we are going to do is, for each and every data record, we are going to find out that for the pair, we are going to find the eigenvector and eigen values. Okay, so here we are going to find out, and then what we are going to do is we are going to find the highest eigenvalue. Okay, so for that, what we are going to do is we are going to sort it. Okay, then only we can find out which is the highest value. Okay, and then what we are doing is we are just going to apply the highest eigenvalue to the each data points. Okay, and then we are going to calculate it. That is the PCA we are talking about. Okay, so PCA, that is principal component analysis. Okay, that is the first principal component, that is with the highest eigenvalue. If you are taking that, we are telling that like a first principal component, and rearrange the original data with the final this principal component that represent significant information. So we are going to transpose each and every data which is present in the data set with this PCA value. Okay, so PCA, how we have calculated, we have found out the eigen vector with high eigenvalue. So we are going to take that first two best, okay, highest value, we are taking it as PCA, and then with that we are going to transposing each and every value of the data record, right? So that is how we are not going to miss anything, but we are going to transpose and we are going to use it. That's why we are telling this process as data extraction. Okay. Right. So this is the syntax for doing for standardization of the data. We are using this scalar, in which we are using standard scalar. Okay, that we are going to import it standard scalar, and then we are going to fit transform X train. We are going to already we have split into train and test data, right? So for that we are giving the transform, right? So this is for standardization. Okay, so to the particular scaling, right? After that, we are just going to find the covariance of X train. Okay, we are going to apply the covariance matrix, and then finding the eigen value and eigenvector. Okay, for that we are using the linear algebra to the eigen of C. Okay, that is the we have found out the covariance matrix, right? So for that we are going to apply the function eigen. So EIG, okay, of C. We are going to apply to each and every information. Okay, and then we are going to sort it, as we know when we sort it in a descending order. So that's why we are giving colon colon minus one in a descending order. We are going to sort it, and then we are going to find out the eigenvalue and eigenvector. Okay, in the descending order, we are going to calculate for each and every values. Okay, so after finding it out, as I told you, principal component analysis, how we are going to find out, that is the first two highest value we are going to take. So that's why we are giving the variable num component as 2, in which we are going to pass that one only, okay, to the 2, right? So first 2 sorted eigenvector, we got it, okay, and then we are calculating the descending order only we have calculated, right? So we are taking the top 2, okay, taking it as like, and then we are going to transpose it, okay. So reduce the data set, so that is eigenvector subset transpose. Okay, we are going to transpose to it, and then we are going to apply this PC1 and PC2 for the transposed one. Okay, after doing it, then we are going to apply this principal DF. Okay, that is concatenation of principal DF and this to the target. Okay, data frame target, we are going to pass on to it across the columns. Okay, so each and every value we are going to apply the principal component value, that is the top PC1 and PC2 that we have calculated and kept it. Okay, so and then it will be completely it will be transformed, right? So when according to the PCA value, the data which is present inside. So here in this data extraction, we are not missing it out, but we are transposing it. So this is the syntax for visualizing it. Okay, so with the X as PC1 and PC2 and the target, and then we are giving a palette, that is the color palette as ice fire, and S equal to 60. Okay, so this is for the scatter plot for showing the graphical representation. Okay, this is for PCA, and this is for the LDA. Okay, so that is linear discriminant analysis. So here the step is only a small difference. Here we are finding the eigenvalue. There we are finding only the first top 2 value and make it as PCA. But here we are selecting the top K. Okay, top K values, eigenvalues we are calculating, and we are mapping to the different data which is present using the dot product of the data. Okay, and the matrix. So that is how we are going to use for the LDA purpose as well, right? So this is the syntax for transforming it into extrain as usual. And here we are using LDA. Okay, so n component which is equal to 1, that is for calling the LDA function, in which we are going to transform to the X train and to the Y train, because every time for the X train the result outcome will be in Y train. Okay, so that is how we are just including for the LDA function in it, and we will get it. Okay, so here this is for the feature extraction process. So now let us go to the uh, code. Okay, so that easily you can understand the process. I will just go through the code little faster. Okay, so that is import pandas. Okay, so I hope you can see here. Okay, so here import pandas. One second. Okay. Right. Okay. So for the yeah. So here we are just import the pandas and then NumPy and then sklan, and then we are going for the data sets. Okay, that is iris data set we are going to have. That is petal length, sepal length, and all. It will be there, and we are going to import that, and then we are going to find the feature selection. Okay, in which we are going to import the variance threshold, and then we are going to use the standard scalar. Okay, for doing this. Okay, analysis. Okay, that is PC and LDA, and then Cboard importing as SNS, and then matplot for plotting the graph. Okay, so first we are going to load the iris data set. Okay, for reading the CSV. This is the stores LB CSV, that is the iris data set, and then we are going for data copy. Okay, so in order to not whatever data which is present inside will be copied to the DF data frame, so that the original file will not be disturbed. So when we put a df.shape, we can see that it has 51 records, rows, and then 15 columns. Okay, now we are splitting the data into the features and target. Okay, so that means feature means -1, that is the last. All the um, independent. Okay, all the independent features we are considered as like okay, and then target is like only the last column, and this is up to the last column. We are taking it as the features. Okay, so as you know from the table, all the independent okay columns we are considered as the features, and only the dependent, where is the last column, which will be the dependent one, that will be considered as the target. And then when we print y, this is the last column. Okay, so that's why we are just printing only the target value. Okay, so target value we are having around 0 to 50, so 51 rows we have. Okay, and then uh, price. Okay, the price only we have just given it here. Okay, right. And now we are going to split the train and test by giving the size as 20% and random shade 42. We can give any value into it. Okay. And then we have X train. The output will be in Y train, X test and Y test. Okay. So we are splitting the train and test. Okay. By giving this particular syntax. Okay. And then X train copy. Okay. That is, we are taking from X train dot copy, and then X test, Y train, Y test, all we are storing it into the variable name. Okay, and we are going to use it. And then first finding out the outlier, as we know. Okay, DF2, that is a new column, and X is the original thing. It will not be disturbed even if we are doing any dropping or anything we are doing. It will not going to disturb the original data set. Okay, so and then for I in okay df2 dot column, that is for traversing across all the columns. We are using the for loop here, and then we are giving the df2 dot d type, that is data type. We are giving it as like object, only the object data type we are taking it out, and then we are putting the condition if it satisfies only the object data type, and then we are finding the value, that is mean and the median. Okay, so object means we can have either character or numerical value. Okay, so that's why we are giving the data type as object, and then we are giving it as like mean, which should be less than the median, right? So if we are consider this condition satisfies, then we can drop it as considering as an outlier, as we know, right? This is like average and this is the middle value, right? This condition satisfies, then we can consider that is as an outlier and that can be removed. So when we do this, one column is removed. So initially it is 15, now it becomes 14, right? And then dropping the features with variance, as we discussed with variance, that means low variance. That is, as I told you, some will be redundant value more, and so that we can remove such column. So for that, what we are doing is variance which is less than the threshold. Okay, so that is the formula we are using here. And all the if condition as usual, we are giving it out. Okay, df of 3 of I dot var. Okay, so it's a function call. And then if this var which is less than the threshold, and then we are just dropping across the y-axis, that particular column is dropped. Okay, and then we are just incrementing the j value as 1. Okay, j equal to j plus 1. Okay, so that is how we are just incrementing and finding the thing. And here we can see that 51 comma 14. So that means there is no low variance. It is again repeating the same. Okay, or otherwise, if you consider directly the df means, df3 means from x, one particular column which has that one, that's why it is dropped, right? And then coming to the drop rates with the correlation greater than 65%, that is higher correlation. Okay, so if we are just checking for it, so we are giving the upper triangle and also the diagonal one. Okay, so that we are just finding out. Okay, so correlation that is greater than 65%, that means we are using this upper triangle, that is the variable name we are using, correlation matrix, where np dot triu, that is the function name we are using. That is the upper triangle, np dot one's correlation matrix dot shape, which is k equal to 1 as type np dot bool. Okay, so in which we are finding out two conditions. One is the diagonal one, we have to miss it out, and the lower triangle have to be removed. If it is the upper triangle, that alone we are going to take it out. And absolute, why we are making the absolute means whenever we are making the correlation between the two columns, we are taking one the positive value. Either then if it is negative also, we are making it into positive, and then we are going to find out only the upper triangle, because as we do, it will be all the values will be like a mirror to the upper triangle, so we are going to remove it. Okay, and then we are dropping across the x train and x test, or across the each column. Okay, we are going to test and we are going to remove it. So now it becomes 40 comma 11. Okay, so we can see that the rows also removed, because we have split it into train and test. So 40 and 11 is totally 51. Okay, and then we can see that 11. Okay, so initially it is 15 and then 14. Now you can see that it becomes, the 15 becomes 11. So 4 have rows or 4, okay, columns, which is like a lower triangle value, right? And then plotting the heat map. Okay, so for that we are just giving the correlation matrix, and okay, annoyed equal to true, and then cool warm. Okay, so that is the map. Okay, and then fmt, that is 2f. Okay, so that is floating point value, maximum of two value only we are kept, have a decimal point, and line width is zero point 0.5. Okay, so that is how we have just given the for the heat map all the values we can give it out, and title as correlation matrix, and then the plot can be shown. Okay, so all the correlation between the all the values, so the diagonal thing can be like 1, and you can see that here 1.10, here 0.10, 0.66, 0.66. That's why I told the upper triangle and the lower triangle value will be the same. So diagonal and the lower triangle have to be removed for the such correlation. Okay, so that's why we have drawn this heat map and uncorrelated independent features with the target variable based on the threshold. Okay, so that we are going to remove it. Uncorrelated feature. Okay, which are all the things that is uncorrelated. That is comparing with the target, which is very low. Okay, so absolute of correlation, which is less than the threshold. Okay, so we are fixing the threshold, which is less than the threshold means we are going to drop these uncorrelated features. Okay, so that is the uncorrelated features to be removed. Okay, and now you can see the shape as 8 it becomes, and for the test also it is 8. Initially it is 15 and now it becomes 8. Okay, because it is uncorrelated features to be removed. Okay, and then feature selection, then chi-square. As we discussed about the chi-square, here we are calculating the chi-square. For that we are checking the target and the features. So this is feature and this is the target. For x and y we are making it out, and randomly we are giving the columns as 0, 1, 2, 3, 4, 9 something, and then across the rows, and then we are playing in place equal to true, and then we are filling which are all the things having no, okay, with the zeros. Okay, so that is how we are filling it out, and then we are applying the select k best model with the chi-square statistical test. Okay, so that is how we are giving it out, and we are fit transform to both x and y values. Okay, and then we are printing the k best features for it. Okay, so here we are not going to remove any particular record, but we are transposed. Okay, so that is the thing we are seeing using this particular chi-square and the k-best model. Okay, in which we are going to implement it. Okay, and then going for evaluating the information gain. Okay, so how we are calculating the information gain for here also we are copying it into a new data frame in order if any modification happening that will not disturb the original data set. And then we are giving the D7 column, selecting the particular column name, and then across the columns, okay, and then in place true. And then here also we are filling it out, and then x and y we are just fixing it out, okay. And then we are using the classification here. Okay, select k best mutual info classif k equal to k best. Okay, so here in evaluating the information gain. Okay, so here mutual info, that is classif x train and x y train. Okay, so when we give mutual info we are getting the array in which the information gain, okay, for each and every combinations we are getting it out. Okay, so this is like finding the information gain, and based upon that we are going to select the features. Okay, and then as I told you, PCA and LDA is the next concepts we are going to calculate. So here we have a series of steps, finding the eigenvalue, and then top two considers that as a PCA, and then we are going to transpose each data in the data set, okay, into the PCA conversion. Okay, and like that we are going to do, and there we are going to find the K. Okay, K top K value. Okay, so likewise that is LDA, right? So here what we are doing here is exactly as usual we are doing up to here, and then we are going to apply PCA, that is PCA function n components, which is equal to 3. Okay, so we are giving the n component as 3, and then we are just going to apply it. When we just call these function, all the steps what we defined in the PPTs, okay, I have explained everything which is defined inside. So simple in Python code, just to call PCA, all that thing will be done at the background, right? Finding the eigenvalue with eigenvector and finding the top, okay, sorting it, and then find after sorting it, finding the in the descending order, and finding the top two value, taking it out and transposing that into each and every data, and we are getting the value. So after transposing, you will get the correlation matrix like this. Right? So this is how we are getting the value for each and every record which is present inside the data set. Okay. And similarly for LDA also, we can do the same thing. Here, just I have to give LDA n component, which is equal to 3, and then fit transform to X train and Y train. Okay. And then LDA transform to X test. When we do here also, we will get the thing. Okay. And finally, how to find the mean value for the mean pixel value for the images when we are giving. So here I have a JSON.jpg. So here we are going to check the two conditions, whether that particular image can be accessed and give the result or not, or if it is given means, if it is a color image means we have to convert it into the grayscale, how to do it, and then we are going to find the mean value of it. Okay, mean pixel value of that particular image. So for that, first reading the path of that particular image. Okay, and then we are going to check whether the image was read successfully or not. So the image is not none. So first we are going to check is not none means there will be some image will be there that will can be read, and then if it is a color image, we have to convert it the color image to the grayscale, right? So gray image, that is to converting it into the gray color, and then we are finding the condition that if length image dot shape which is equal to 3, okay, else image, right? Okay, so we have to check this particular condition for okay, this conversion part, and then calculating the mean pixel value. So here we have the image we found out, and then we are finding the mean value of it. So mean pixel value which is equal to gray image dot mean. Okay, so this is the function name we have to give. So if we are if the particular image which is can be accessed and converted into grayscale, and then this mean is found out, then we are just printing the mean pixel value of the images. What is the value we got it? Otherwise, we can say the condition that the image not found or unable to read the image. So here that particular image jesus.jpg which is read, and then it is converted to the grayscale, and also the mean is calculated. So we are printing the value as the mean pixel value of the images. This is the value of it, right? So this is how we can do pre-processing steps. We have seen, okay, when it is an outlier, or how to make a scaling. Okay, and then we have seen so many conditions like LDA, okay, and PCA. Okay, so different ways how we can do the pre-processing. Okay, steps. Okay, before passing to the ML model. This is very much required. Then only the accuracy of the complete analytics will be improved. Okay, so that's why we are doing this feature selection and feature extraction. So this is called the feature engineering. Okay, so this have to be done before passing to the ML model. Okay, so soon I will go for some other exercise problem so that easily you can know the next step what we are going to have. Right? I hope you understood the steps. Okay, so do the exercise and all the best. Right? Okay. Thank you.